In this example, we're going to be looking at the graph of the sine function. For more videos on this unit, visit parkermaths.com/Y1 Trig. So let's sketch the graph of y equals sine x in the domain negative 360 degrees is less than or equal to x, which is less than or equal to 360 degrees. We're going to do this with some help from the unit circle. So we're going to start with a unit circle diagram showing theta equals 30 degrees. And on the right hand side, we're going to build up the graph of y equals sine x in stages. To help us do that, we're going to plot some points that we know on the graph. For example, with sine 30, we could mark 30 degrees on the graph, and then we could extend the horizontal line, which represents the y coordinate on the unit circle, to mark a point where x is 30 degrees on our graph. And we can do that for various values that we know, which should give us some information about the shape of the graph. But rather than start with sine 30, I'm going to reduce the angle to 0. From work we've done earlier, we know that sine of 0 is 0, so let's plot that as our start point on the graph. Next up, we'll go to 90 degrees. We know that sine of 90 is 1. Moving along another 90 degrees gets us to sine of 180, which we also know is 0. We can continue a further 90 degrees to get to 270. We know at that point we've got negative 1. We can then go another 90 from 270 to get to 360, and we find that sine of 360 is 0. Having plotted those first 4 points, we can see the graph goes up, comes back down, goes below 0, and then goes back up. But from these 5 points alone, we don't have enough information to really plot the shape of the curve. So let's add on a few more points that we know the values of. First of all, we know that sine 30 is 1/2. So let's plot that. Next, we might move along to 45. We know from looking at the exact values that sine 45 is 1 over root 2, which comes out at approximately 0.71. Something that's worth pointing out at this point is that 30 degrees is only a third of the way to 90. But at 30 degrees, we've already gone half of the way up. So we've started out quite steep. But then 45 degrees only gets us 71% of the way up. So we can see that as we go along, this graph is getting less steep. Let's continue to 60 degrees. Sine of 60 is root 3 over 2, which comes out at approximately 0.87. Let's plot that on our graph as well. Now we could draw a line in there, but before we do, let's use something we know about sine theta based on the unit circle. We know there is a symmetry about the y-axis, and that means there's a few extra points we can plot, because we know sine 120 degrees will take the same value as sine 60. We know that sine 135 degrees will take the same value as sine 45 degrees. And we know that sine 150 degrees will take the same value as sine 30. So that gives us the shape of half of the graph. To speed things up a bit, we can take a look at the unit circle and see that when we get past 180, the graph is going to have the same pattern as when we're above. It's going to go down to 270, but getting less steep as it approaches. And then it's going to go back up to 360. And we could, using our knowledge of the unit circle, plot out several points between 180 and 360 as follows. And so plotting the curve between 0 and 360 gives us this shape. And so here we have the graph of y equals sine x between 0 and 360 degrees. But there's nothing here to stop us extending this graph. There's no reason we have to stop at 360 degrees. We can continue to go round the circle as many times as we want. So for example, we could draw the first 720 degrees of this simply by continuing round the unit circle as follows. And what that shows us is that this graph repeats itself every 360 degrees. And the way we would say that mathematically is that the sine graph has a period of 360 degrees. We could also go clockwise around the unit circle, and that will show us what sine x looks like for negative values. So starting at 0, going clockwise takes us through the negative values, and we can see that we end up with the same shape as we do for between 0 and 720. And so we could carry on indefinitely in both directions for as long as we wanted to graph more of y equals sine x.